Thank you very much, Mark. I got the best slot right after lunch when everybody's in a coma, so that's awesome. I'm going to speak for a few minutes on monitoring and alerting, and then I'll bring up Deniz. This morning, you got an introduction to monitoring and alerting from Russ as he went through his 20-minute presentation on setting up monitoring. I'm going to slow it down a little and make sure we understand all the pieces for monitoring and alerting. So we're going to slow it down just a bit so you understand this very important feature, obviously, for us and all of you. So what I'm going to talk about is the vision for the monitoring and alerting features, the building blocks of the monitoring and alerting, a couple more just touch on how we think these features could be more powerful with some tags and leveraging the status and notification messages a little bit deeper with the string interpolation that Russ mentioned, and then we're going to go into the engineering deep dive, and that's when I'm going to hand it over to Deniz and really get into the weeds and really get your hands dirty and some pretty cool stuff on actually how the thing was built. So to get a little bit into how it was built and why we built it, we wanted an easy-to-use interface for everyone. We wanted users to come into the product, not know anything about Flux, not necessarily know anything really about time series database, but use a point-and-click interface to get through the different parts, end up putting this data on a dashboard and saying, you know what, this data on a dashboard is really, really important to me if X happens or if Y happens. Please let me know. I can't be sitting in front of this dashboard all the time. And so, of course, we have this monitoring and alerting feature. So a point-and-click interface, which I'll go through and demo step by step. And then also, really, this was the first time that we took the platform, the database pieces that we had been working on over the last year and a half. And instead of building something really low level, we came in and said, you know what we're going to do? We're going to give that higher level functionality on top of these primitives. But at the same time as making it easy to use, we have all the pieces for all of you to get down and really use all of the bits. And so I say, you know, power users unite, right? All of the power of the platform is there underneath it. And this can guide you in understanding exactly how the different pieces fit together. So let's ease on into it. The building blocks of monitoring or alerting are monitoring checks, notification endpoints, and notification rules. I'm going to go through the terminology because it helps to understand all the little bits to get them right in your mind. So a check is a query. It's simply a Flux query, so you have the entire power of the Flux language available to you to query your data and come up with some time series. A check is going to analyze that data and analyze the result of the query, right, and understand what it thinks its current status on that check is. Now, tags are just key value pairs that you can apply to any of the checks, and we'll get into why we think that could be useful later. Statuses are every interval that I do a check, what is the status that I think that I'm at? It's analysis. We'll get to it in a second. All of that data, all those checks, every time you run them, all that data is actually written into a monitoring bucket. And there are two different types of checks right now that we support. There's the threshold one, where I check the values of my time series data against particular criteria, and I understand which level I'm at, or a dead man, which is if I'm reporting data in and it stops reporting, let me know that. This is really useful for when you're monitoring things, anything, that you always want to make sure it's up and running. Dead man checks are useful for that. So that covers the majority of the terminology around checks. The next point is the notification endpoints. And these are pretty simple. These are the just configuration for how you call third-party services. We support 3 right now. We plan on supporting more, but we've got Slack, HTTP endpoints, and PagerDuty out of the box right now. You can get those on OSS. All three of them are available there. On our cloud offering, Slack is in the free tier, and the paid offerings are for the PagerDuty and the HTTP endpoints. So those are available today. The notification rule is the last building block. It's the part of the system that tells me, okay, I've got all these checks running. They're going every so often. The rule says, okay, when X or Y happens, I'm going to send a message, and it gives some parameters around that. So not everybody has to get paged by every single alert. So there's the rules around that. And then all of that data is also written into the time series database as well. So those are the three building blocks. And what I'm going to do next is pull it all together into a simple example. It's not the most exciting, but it gets the point across. We're going to monitor some CPU data. We're going to put a threshold check on it and make it, trigger it to be stressed, and then it'll send me that notification. And then I'm going to walk you through a dead man check and then also trigger that notification. So let's go ahead and go into the demo. Alrighty, this is not exactly go right, but I think I can make it work. All right, so I'm going to create a threshold check, and Russ kind of walked you through this earlier, but the first step in creating a threshold check is telling the system what query we want to look at. And we're going to go ahead and look at the CPU usage of these particular CPUs on this box that I already have reporting in. And we've got the query. This is the data over the last hour or so. So that's the first step. So you move on to the second step of saying, okay, what exactly what are the thresholds we want to put on here? So I'm going to go ahead and label this the high CPU check. And we can check for different intervals, every minute, every 15 seconds, every 5 minutes. I'm just going to go ahead and every minute. I'm going to add a tag on here. Let's just say that this is in the department, the finance department. And I'm going to say, here's my message. The level is, when the level is okay, also for this CPU, and I'm going to add some interpolation here for all the values in my check are available, and I'll go ahead and show that to you in a little bit later. But for that CPU in the department, So that should be a pretty straightforward message that will come across. I'll show you how it comes across in a second. Then we'll go ahead and add a crit and say when this value gets above 50, that's going to be my critical state. I could add a warn here. And what's pretty neat here is you can also, you don't have to be an expert in understanding all the numbers. You could just use the point and click interface to say, okay, well, around here, that's where I would like to be warned. And then I could also say, I'm okay if any of the values are below, let's say, 20. Right. So there you go. Oh, gosh. My department. Well, let's take it out for now. And make sure that I don't. Gotcha. Well, it's too late now. We'll move on. Okay, so I've got my check, high CPU check. So from here, the next step, I'm going to create a notification endpoint. And these are pretty easy to set up. I'm going to go ahead and just say, hit my Slack. I've got over here on my other browser the webhook. I'll go ahead and show it. If you go over in Slack, I'm not going to walk through the entire way of setting up your Slack endpoints, but they're basically webhook. They're really easy if you have Slack privileges. So I'll go ahead and add the Slack endpoint. right in here. All right, so now I have a notification endpoint, and now I'm going to finish off by creating the rule. So notify me, Slack. Now I can run this every, check for the status every 5 minutes, every whatever period I want, and then when I decide, when it checks it, that's when it's going to send me the notification rule. So there's a lot of flexibility in your scheduling and being notified. I'm going to just check every minute. When the status is equal to crit, I'm going to go ahead and send me that notification. All right, so on my other screen over here, or I got it up here, I'm going to stress my CPU. And while we're walking through this, I'll get a notification here in a second. But while we're waiting for that, I'm going to go ahead and create another one, create a dead man check. And the dead man check, I'm just going to check on the same exact values. When the CPU stops reporting is what I'm going to look for. It's reporting right now. I go over to the check, name the check. I'll call it a dead man check. Dead man. I'm going to check every minute. And I will attempt again my tags, and I'll say that the department here is IT. And when the message comes along in the $sign department. So that would be my status message. And right here, I've got some options here. I'm going to say, you can say, let me know if it stops reporting after 90 seconds, after a minute, whatever makes sense for you. In this case, I'm going to say 60 seconds. But also, we've also added this option, stop monitoring this after a certain amount of time. A lot of times, the things that we're monitoring are, they're temporarily around, and perhaps they're expected to, if they do stop reporting, we don't expect them to come back. Stop letting me know about it. So we've got an option here to stop letting me know after, let's say, 20 minutes. So I'll go ahead and save this dead man check. All right. And if we switch on over to my Slack, we can see that it is reporting. I did want to hit up on the view history of the CPU check. We can come in here and see that the, hopefully that's big enough for you, the actual value at every interval. And you can see that the message actually did come across as the high CPU check is crit for this CPU, CPU3. So that's where the interpolation comes across. All righty. Oh yeah, the dead man check. So what I'll do for the dead man is I will tell my telegraph to stop reporting. And then over here on my Slack side, that message came through. In about a minute, we should see the dead man come through. I'll come back to this. I do want to hit a couple more slides before I hand it off to Deniz. There's a few ways that we think that you can use these tags, and I just wanted to seed some ideas with you. We could use those tags in the separation of my rule, saying, okay, I want to pick up this rule, this notification when the tag equals finance versus the tag equals IT, or perhaps different lines of businesses, departments. So separation of the tags and the notification and the interaction, we really think that these tags can really powerful in separating that, maybe separate your location. I get a particular message only if the LA data center goes down, separation of criticality, notify the dev team about dev issues and notify the production team about production issues. And in hand with those tags, we believe that's the string interpolation, the actual statuses and the notification messages give you a lot of flexibility to use those tags and all the values from your query. So I just want to take 1 second after we hit Slack. notification rule for the CPUs. All right, we can go back to the status. CPU check, okay. We go to the deadman check, which is not spelled correctly. I am in a crit, so I do expect myself to get a message on the Slack channel in 1 second. I'll come back to that. The nice thing about the system, and as I mentioned, we've built them on the primitives of the platform themselves, which means you have access to the buckets. So if I come in here to the monitoring bucket and the statuses, and if you're ever wondering, you know, in that message, what bits can I actually use and what are valid, you can go to the monitoring bucket, query it, and look at the raw data, and everything in these columns, all of these are the data points that you can use to bring across the measurements, the values, the CPU, all of that is available to you. And so it is here on the system and is accessible right here in the monitoring bucket. All right, so next I want to bring up Deniz. So Deniz has been working really hard on alerts and notifications for the last 3 months or so. So she's really going to dig into the weeds for you, and I'm really excited to hand it over to you.
Thank you, Nate.
There you go.
Hi, everyone. Yeah? Keep going? Okay, that sounds more like, thank you. Hi, I'm Deniz. I'm one of the engineers working on the UI team, and I wanted to start my slides with a moment of appreciation for Chrono Giraffe, the mascot of our chronograph. So that's it. Bye, Chrono Giraffe. So Nate took you on a tour of our new monitoring and alerting feature, and I wanted to tell you the story of how we built it. And I want to argue with this that the architecture decisions and our process in building out this feature can be a guide for how you can use the primitives and APIs that we've built as part of the InfluxData v2 platform to build your own complex business logic. So how we built it, and you can too. Because really, over the past year or so, in every engineering team across Influx, we've really taken a step back and started working on the building blocks of our v2 platform. We've built a multi-tenanted version of our database and made it available on the cloud, of course. We've built Flux, which is a combined scripting and query language for all your data analysis and queries, which is not only expressive but also extensible, which we'll get into later. We built a task service that allows you to run Flux queries on a schedule. And in order to make it easy for you to interact with the resources that we make available, we've built a developer-friendly API. In order to make it easy for you to interact with the API, we've built client libraries, a UI component library, and a visualization library. I'll be talking about these later. So what we were trying to achieve with our monitoring and alerting feature was to make it super easy for our users to go from visualizing and exploring their data to building complex alerting and monitoring, and really being able to specify when and where they'd like to be alerted as their underlying data changes over time. So that guy's really cute. And we built this two-tiered system that Nate just walked you through, and I'll kind of go over again. What's happening is that we have checks and notification rules. Checks are running on the data bucket, the user's defined query, at regular intervals. So this is one check, this is another check. And this is the demonstration of a threshold check, for example. And each time a check runs, it makes an evaluation of the window that it ran on and outputs a status to the system, special, slightly protected monitoring system bucket. So here, all of my data was underneath this threshold, so I got an OK status. Here, my data was above this threshold, so I wrote a crit status. And what's you can see about this is status messages are actually just time series data. So we put it in a monitoring bucket just like your original data. Notification rules also run on a regular schedule, but this time they read from the monitoring bucket and evaluate the statuses. In this window, I only have OK statuses, and in this window, I only have crit statuses, so only this notification rule will cause an alert to be fired. And so instead of building an entirely new feature, we actually used the primitives that we'd already developed, namely tasks and flux, extending flux with a monitoring package. I'll get into this more later. And so the checks and notification rules that I just told you about underneath the hood is just tasks executing flux, and notification rules are also tasks executing flux. Let's look a little closer. I look like I'm missing a slide there. Okay. So as the user, we really wanted to make this easy to use. But as the user points and clicks through the UI, like so I'm going through and building a check right now. I've defined a query. This is my CPU usage user query, and I can define my check properties. What we're doing is we're building a JSON representing the check, and we're also templating a Flux query and filling in the properties that they've defined to build a custom Flux query for them. So I built a little widget to kind of show you what's going on behind the scenes, and it's like live and cool. Okay, let's zoom into that a little. Oops. Yep. So you can see, like, as I change the name, you should be able to see. I don't know if you can see that. It's live. Okay. So each of these fields is represented in the JSON and also in the Flux query. So I'll just kind of quickly go through these. This part is just the query that the user wrote, whatever query they want to, whatever data they want to write the check on. This part is just business logic, like what's the name of the check? What's the type of the check to be able to construct this Flux query? This is the tags that they've defined. So what tags do they want to add to the statuses that might not be available in the original data? And we've created functions that just output whether or not the data that's coming in is above the threshold or below the threshold. And this is the message function where the string interpolation happens. And here you'll see something. All of this is just readable, regular Flux. One thing that you might not recognize is this monitor package. So at the top of this also is that we've imported a new monitor package. And so for this, we extended the Flux language, and we're using this monitor package in both the checks and the notification rules to be able to synchronize them so that they can talk to each other, and also to abstract away more complicated parts of the Flux query so that we have to, all we have to template is something simple and pretty like this. And so we're consuming a Flux query and outputting another Flux query and writing to the monitoring bucket. I can just quickly show you the notification rules as well. Again, as I change the name, this is all live. Here again, I've imported the monitor package and some helper, HTTP and JSON. And I'm creating a headers. And one thing you'll notice here that I wanted to point out was the secrets package that we used from Flux. This allows you to write safe Flux, even though the logic that you rely on requires secrets. So we required this is an HTTP endpoint, and so we needed a username and password, but we didn't want to write the username and password as string in the Flux query. So we wrote the username and password to the secret store that the Flux query can access without exposing it. But here too, before we were using the monitor.check function, now we use the monitor from and monitor notify. And this allows both the checks and notification rules to speak together reliably. Like this part of it can change, the user can give us different options, but we know checks and notification rules can speak to each other. Okay, so checks are tasks executing Flux, notification rules are tasks executing Flux. But as a user, you don't ever have to know this. So thank you so much for your patience in coming through that well of Flux with me. But as a user, especially the team that I'm on as a UI engineer, working with designers, we are committed to creating point-and-click, intuitive interfaces that allow you to build complex tools that serve your needs. So we'll allow you to make it easy to load your data, build dashboards, set up alerting. We will do that for you. And as a user, we'll also give you easy tools to create queries. So you can like build the query using a query builder and then jump into the script editor to see the Flux that's running behind the scenes. So you don't have to know any of these. But what's cool is that as a developer, your experience with InfluxData platform is really a choose your own adventure. You can choose the level and flexibility, the level of flexibility and control with which you want to engage with our platform. As a developer, you could use the monitoring package, which we've made available to write more complex logic that suits your needs perfectly. And you can use the monitoring bucket monitoring package to write to the monitoring bucket and read from the monitoring bucket. Or as a developer, you can extend or use parts of the UI. So these are the component libraries that I told you about earlier. Clockface is our UI component library, which is just here. So every UI element from buttons, inputs, navigation, overlays are all available as components that you can drop into your application and use as you will. And also, we have a new giraffe visualization library, which is the graphing part of our UI. So that also, I'd really encourage you to take a look at it. For any kind of plot that we use in the UI, we've made them layerable and componentized. So you can drop that into your application as well. As a developer, you can use our API to drive your own application. So we've built client libraries in a number of languages. We've documented them extensively. And so if you want to use your app but have Influx behind it, that should be easy. And as a developer, you can harness the power of Flux. You can write your own Flux queries and use the client libraries to hit the query endpoint. And you can write your own, just like we wrote the monitoring package, you can write your own packages. You can use the package system to create an API which encapsulates complex business logic. And what's really cool about this is that you can use Flux packages to standardize logic across your organization. Let's say you want to standardize how your colleagues read and write from Influx or certain functions that they want to do. You can just pass them a package and let them use that instead of sending them scripts. And yeah, that is also documented. And if you want to learn more about how to use Flux packages, Nathaniel is giving a talk tomorrow at 10:20. I would highly recommend it. So that's all I have. It was really cool to be one of the first consumers of the primitives and APIs that we've been building over the last year. It really feels just so flexible, and I'm really excited to see what you guys build with it. I do have one ask, though, is that you keep in touch. We have community, the Influx community Slack, and you can always file feature requests or issues on GitHub. So yeah, thank you.
Any questions for Deniz or Nate? You're going to take questions? Yeah, I have lots, so I'm going to go first. No, I'm teasing.
Tomorrow's talk would be good. I don't know if we have documentation available on Flux packages that I can point you to right now. Yeah?
There's a contributing doc in the Flux repo to help you get started. But yeah, the talk would be a great place tomorrow.
Yes.
Hello, I have a question.
Sorry.
So in terms of 2.0, how does support geographic data?
Sorry, say that again?
How does 2.0 support geographic data?
In terms of, I know more of the UI, and we've been excited about geographic data for a really long time, and we're really excited to extend our visualization library to support that. In terms of the database, I think somebody else is going to have to answer that.
The answer is it depends.
Okay.
Oh, come on, Paul.
Yeah, so it depends. You can, depending on what you're doing, you can store like lat longs as field values, or you can do like the thing where you have geographic zones and have those indexed as tags. But geolocation stuff isn't like first-class citizen in the database just yet. So you can do things with it, but it's kind of like you're kind of shoehorning it in there. It is on a roadmap to add, but that's not something that'll be like first class in 2.0 when it gets released. It's a more forward-looking thing.
A question. It looked like Nate set up a check for once a minute, but you later showed what looked like a window of time that check looks back over. Yes?
Yes. So it runs once a minute, but you can decide how far back it'll look into the time window between the last check and this current check.
It's not just an instantaneous, was it high or low at that
No,
instant?
and you'll have to define an aggregate function, so you can say, within this window, if the max is above the threshold, or the min is below the threshold, or the average, there you can use any aggregate function.
I just want to quickly say, excited about the unification of the capacitor and the SQL query language, or the InfluxQL query language. It's great to see Flux. My question is about templating. How does capacitor had that notion of templating? How does that look like in 2.0 with Flux and tasks and checks?
Do you mean like variables within Flux?
Yes, yes.
So,
basically, the use case would be like, I might have 60 databases. I want the same dead man, same CPU alert applied across all of them without having to write 60 checks and texts.
Exactly. Yeah. So I don't know if you'll be able to easily do that with checks. I'll have to think about that. But for any query, the query endpoint accepts the text of the query, but also an extern field where you can inject variables. So no, okay, you're running. Okay.
Yeah.
No, tackle.
So there are multiple ways to tackle this problem. If you already know you want to run a dead man against everything that has a certain tag, you just define a check that has a query that queries for all of that data. If you want to have it be something more dynamic, you could, for instance, have a relational database which has a list of things that you want to check. And then within Flux, there are connectors to pull data from Postgres or MySQL. You can actually query the list of things that you want to check out of that database, and then use that to construct a query that says, give me all the time series data that matches these things, and then compute something like, say, if the 95th percentile over the last 10 minutes is over some threshold, then trigger this status. Conversely, you could store that data actually in InfluxDB itself. So you could have a separate time series that is basically just the keeper of, here are the things I know I want to check later. and then you query that, and then join that with the actual time series data. So all that is actually possible in Flux, or yeah, in Flux today, in the language Flux. So yeah.
Don't get down. There might be more questions.
Stay.
Come
Any
on,
more?
some more questions. Test 4. I don't. Deniz is fine, but yeah, let's put forward the test. I have some questions. When is the ship? No.
No, I have a question, and I don't need a microphone.
Good.
Okay.
Speak up then. Yeah.
Is it possible for one script?
I think they need it for the live stream.
Is it possible for one script or for one monitor to generate several alerts in the same run?
Yeah, it will create one for each of your series.
Yeah.
So if
okay.
there were multiple CPUs, it would create a check
yeah.
for each of those.
Yeah. So if we have multiple servers and 2 are disk full, we will get 2 alerts.
Yep.
Good. Thank you.
I just had one follow-up about the templating alert thing. We found that in 1.0, our use case was, we found it nice to be able to like almost disable a certain check that was templated. So like across the 60 databases, we know one of them is going to alert with the CPU. We just want to disable that certain check, but still use that templated infrastructure. That's maybe one thing nice about having templating be maybe considered first class in the system. But yeah, that's one of the use cases that came up in the last couple of weeks that I just wanted to mention.
Okay, yeah, that's right now you can mute, you can just disable an entire check or mute a notification rule. Having something more dynamic like that is definitely something that we will be adding. You can, like I said, you can use the primitives right now to hack that in. The goal is to expose something that's a little bit more standardized and easy to use in the user interface, so you can do that, right? The perfect example is, I'm about to do a deploy, don't alert me on this thing that I know I'm going to bounce or whatever.